Welcome to a lesson on triangle congruence by side angle side. In the diagram here, we have two triangles where we have two sides marked and an angle that's marked that's what we call included or between those two sides. On the first triangle at left, if you look at angle A, notice it's between or what we call included these two marked sides. Also, on the other triangle, we have the same thing going on. Angle R here is between these two sides, and we've noticed that those two sides and the corresponding angle or the included angle are marked as being congruent. Well, this is enough for us to know that the two triangles are congruent. We can state confidently that triangle ABC is congruent to this other triangle. Now, let's be careful when we do our naming convention. Right? Angle A, what angle does that correspond with? Well, it's marked as corresponding with angle R. So that means we would put R first here. Okay. Then B, what angle corresponds with B? Well, you got to be careful here. Notice that A and B are on the side marked with a single mark. And so since we know A corresponds with F, R would go along the side with a single mark to S. So it would be R, S, and then Q. Have to be careful about the convention. Let's take a look at a GeoGebra construction just to see how this plays out, that there's in fact only one unique triangle with that we can draw if we're given two sides and an included angle. So let's pretend that this side length is 3, this side length is 5, and the included angle, let's give it a measure of 60 degrees. Let's go over to GeoGebra and realize that with 3, 5, and 60 degrees, there's one and only one way to make this drawing. All right, so going over to GeoGebra. First, you might go to angle with a given size. I'm going to click that into my drawing here. So let's see. Angle with a given size. I just realized I did not draw that at 3. Let me cancel that. No, I did draw it at 3. Okay, well, never mind. 3. All right, so I want 60 degrees. And let's draw that in. So notice what I've drawn there is I've drawn a line segment AB. And let me just go ahead and draw that in. I've drawn it so that it has a length of 3. And then I have a new point. It's labeled as A prime so that it's 60 degrees. Well, if I put a ray from B through A, I know that that's going to be somehow my second side. So let's do that for just a second here. Ray from B to A. Now, however, I don't want it to go indefinitely. Remember, my challenge was to do 3 and 5 with an included angle of 60. So I want to figure out where is exactly the distance of 5. So the way I do that is I pick circle with center and radius. I put the center at B, okay, and then I make a radius of 5. Now what happens is it intersects that ray down there at a distance of 5. That's the radius. So I'm going to put a mark there. Okay, then you can go back and turn off this circle so it doesn't distract you. Okay, it's there in the background, but it's not there. You can also turn off this ray if you'd like to do that as well. And in fact, you can actually turn off A prime if you'd like to as well. So let's see, I'm going to turn that off. Now what we have here is we have a polygon where AB is 3. I didn't turn that point off, but it's okay. There's C is 5, and there's one and only one way to do that. So there's my triangle with 3 and 5 included angle 60.